The Mi-8 is a medium twin-turbine helicopter, originally designed by the Soviet Union, and currently still being produced by Russia. In addition to its most common role as a transport helicopter, the Mi-8 is also used as an airborne command post, armed gunship, and reconnaissance platform. Along with its export version Mi-17, the Mi-8 is the world's most produced helicopters, with over 17,000 units in use on more than 50 countries. Its prototype flew on 1961 and entered mass production at the end of 1965, but the Soviet military originally showed little interest and the type entered service almost 2 years later, during 1967. The Mi-8 version simulated on DCS is the Mi-8 MTV-2, which can carry weapons and can also operate as a flying crane. Unlike a jet aircraft, where your engine throttle directly controls the aircraft thrust, on a helicopter you set the engine throttle to a fixed level, and then use a collective lever to change the pitch of the blades of the main rotor, thus adjusting the thrust that the main rotor produces. Rudder pedals are used to adjust your tail rotor's propeller pitch, to provide a lateral thrust to control the yaw of the helicopter. The cyclic is used just like a regular stick on a plane. The cyclic modifies the orientation of the main rotor, allowing you to control the pitch and roll of the helicopter. Make sure to bind the following axes to your HOTAS device, on the Controls tab of DCS Options: Flight Control Cyclic Pitch, Flight Control Cyclic Roll, Flight Control Rudder, Flight Control Collective, Corrector, Throttle Adjustment on Collective Lever. The real Mi-8 carries a crew of 3 or 4 members: Pilot Commander, Co-Pilot Navigator, Flight Engineer, Gunner. Someday, this DCS module will have multi-crew enabled and each crew position will be able to be manned by a real player. For now, you can select which crew position you want to sit on, by pressing the keys 1, 2, 3 or 4. Try it, press 2 to change to the co-pilot seat. You are now on the co-pilot navigator position. The co-pilot shares the pilot's duties and also assists the pilot with navigation duties, as most of the navigation and radios are near this seat. Check your range of movement and field of view. You can click on the Windows handle to open-close it. Press 3 to change to the engineer seat. You are now on the flight engineer position. His duties include monitoring the engines, electrical system, autopilot status, and radio communications. Check your range of movement and field of view. This is the best seat to use while performing most of the cold start. Press 4 to change to the gunner position. This is the gunner position. You can use the mouse to aim the gun, left click to fire it. Check your range of movement and field of view. Press 1 to return to the pilot seat. You are now back on the pilot commander position. You can click on the Windows handle to open-close it. In addition to selecting your seat, you can also use the keys Right Shift plus P, to toggle the crew bodies visible or hidden. Try it now if you want. Press spacebar, to continue with the next training subject. To save time, in case you are repeating this mission, you can press spacebar, to skip most voiceovers. Since DCS aircrafts always have perfect reliability, you can be sure that all helicopter systems are fully functional. Because of this, many players never bother to perform the checks and tests that real pilots have to perform in real life, in order to save time when starting a game session. However, in case you do want to learn how these tests and checks are performed, this training mission has 2 versions. Press backspace if you wish to learn the tests and checks in order to have a better understanding of the systems. OK. You have selected to perform all tests and checks of the cold start procedure. 8.13. Pre-start checks. Please, move over to the flight engineer seat, with the 3 key. 1. Enable circuit breakers. Enable the banks 4, 5, 6, 7, 8 and 9. By clicking on them or by pressing the keys Right Control plus Right Shift plus 4 through 9. The circuit breakers of banks 1, 2 and 3 power the weapon systems, so they don't need to be enabled at start. 3. Check that the clock, on the co-pilot console, is set to the correct mission time. On DCS the clock is always already set correctly, however, press backspace if you'd like a refresher on how to use and set the clock. Press spacebar if you prefer to skip this. To set the time, First, stop the clock by rotating the right silver knob counterclockwise, using the mouse wheel. Next, right-click its left red knob to pull it out, and then use the mouse wheel to set the desired time. For example, set it to 9:45. Right-click the red knob again to push it onto its normal position. Now that the clock is set to the correct time, start it by rotating the right silver knob clockwise, using the mouse. The clock contains two inner spheres. The top one is used to keep track of the mission time, in minutes up to 12 hours. You start the mission time by left-clicking on the left red knob. Do it now. Inside the mission time sphere, there is a colored square status indicator, with the following meanings. Red: mission time is running. Red-white: mission time is stopped. White: mission time is reset to standby. You change status by left-clicking on the left red knob. Currently it is red as we just started the mission time. To stop the mission time, simply left-click on the knob again and it will stop and the status changes to red-white. The sphere indicates the elapsed mission time. Click on the knob once more to reset the mission time to 0, the status changes to white. The bottom clock sphere is a stopwatch, used to accurately measure short time spans, up to 1 hour. It is controlled with the right silver knob, in a similar fashion as the mission time clock. Left-click the right silver knob to start the timer. Once the event has lapsed, just click it again to stop the timer. Click it once again to reset the timer to 0. Good. This concludes the how to use the clock procedure. 5. Overhead fuel shutoff levers. Check they are in the closed back position. They control the fuel valve in the fuel control unit of each engine. When closed, the fuel diverts to the drain line. 6. Main and auxiliary hydraulic switches. Confirm they are on, up. For redundancy, the Mi-8 has two independent hydraulic systems, main and backup. They power the flight controls of the collective. The backup system activates automatically if main system pressure drops below 30 kg by squared centimeter. 7. Fuel crossfeed switch. Confirm it's set to on, up, on the fuel system panel. Allows crossfeed of fuel on the external tanks. It would be set to off only if one of the external tanks was not mounted or suffers battle damage. 8. Fuel bypass switch. Check that it is set to off, down. Allows connection of one or two removable auxiliary fuel tanks mounted on the passenger compartment. Not simulated on DCS. Battery 1 and 2. Set to on, up. This will connect each battery to the 27-volt bus and are used both as emergency power supply and to start the engines. DC check selector. Set to battery bus. This connects the battery bus with the DC instruments. DC voltmeter, batteries 1 and 2 amp meters. Make sure that the standby generator switch is off. Check the battery bus voltage on the DC voltmeter, which should read 24 volts minimum. 11. Annunciator switch. Set to day or night, as needed. It adjusts the brightness level of the cockpit annunciator lights. 12. Set the RI-65 audio warning system switch on, up, to enable the nagging Natasha. The turn on RI-65 annunciator goes off. At this point, the system will warn about low hydraulic pressure and fuel pumps not operative, which is correct. If you'd rather not hear Natasha, then leave the switch off.
Main hydraulic failure.
Cockpit equipment checks. 1. Battery condition check. 1A. Confirm that the DCE external power switch is off. 1B. Turn the DC check selector knob to battery 1. 1C. Set the battery 2 switch to off, to check the battery 1 alone. 1D. Start the service fuel pump, to place a load on the circuit, and check the DC voltmeter, which should be not less than 24 volts. 1E. Turn the DC check selector knob to battery 2, 1F. Set battery 2 switch to on, 1G. Set the battery 1 switch to off, to test the battery 2 alone. 1H. Check the DC voltmeter, it should read not less than 24 volts. 1I. The battery check is finished, turn off the service fuel pump. 1J. Set the battery 1 switch to on. Now both batteries are connected to the battery bus. 1K. Turn the DC check selector knob to battery bus, to leave the voltmeter displaying the battery's combined voltage. 2. Fire extinguisher system check. Press backspace, if you'd like to watch a short presentation on how the extinguisher system works on the Mi-8. Press spacebar, if you prefer to skip this presentation. The Mi-8 fire extinguisher system. It protects 4 areas of the aircraft: left engine, right engine, main rotor transmission bay, and KO-50 fuel heater. The system has 42 fire detectors, arranged into 14 groups of 3 detectors each. These 14 groups are arranged into 6 redundant detection channels. Channels 1, 2 and 3 cover the left engine, right engine, and transmission. Channel 4 covers the transmission. Channels 5 and 6 cover the fuel heater. On the diagram, the channels are color-coded. The system has 2 extinguisher bottles. Main, first discharger 1, and alternate, second discharger 2. Bottle 1 should operate automatically when a circuit detects a fire, but it can be fired manually by pressing one of the 4 round first discharge buttons of the fire extinguisher control panel. Bottle 2 only operates manually, with the second discharge buttons. Each fire bottle has 4 valves, corresponding to each of the 4 protected compartments. The fire bottles are mounted on the right side of the main gearbox deck. 2A. Switch off the command radio circuit breaker, on CB bank 7. This is necessary because the system is programmed to send a radio alarm message on a preset frequency whenever it detects a fire. 2B. Confirm the fire extinguishing discharge circuit breakers are off, on CB bank 8, to prevent accidental trigger of the dischargers during the test. 2C. Alternately set the bottle selector switch to 1 and 2, to make sure both sets of extinguisher bottles igniters are OK. If the amber lights on the fire extinguisher's panel illuminate, then the bottle is faulty. 2D. Set the extinguisher's mode selector switch to detector test, and observe the red detector test light turns on. 2E. Next we will check the fire detection channels. Set the monitoring selector knob to channel 1. If the channel 1 is good, the lights fire left engine, fire right engine, fire KO-50 and fire transmission APU should illuminate. The fire light on the pilot console should also turn on. If all the lights are correct, advance the monitoring knob onto channel 2. The same lights as before should remain illuminated, as this is a redundancy channel. Next, advance the monitoring knob onto channel 3, 2F. Upon setting of the selector knob to channel 3, the fire KO-50 light should go out. Next, advance the monitoring knob onto channel 4, 2G. With the channel selector knob successively set to 4, 5 and then to 6, the fire transmission and APU light should illuminate and the other lights should go out. 2H. Good. After checking all 6 channels, set the monitoring selector knob back to off. 2I. Set the extinguisher's mode selector switch to extinguish. The red detector test light goes off, denoting that the system is operative. 2J. Switch on the command radio and fire extinguishing system circuit breakers. Good, the fire extinguishing system is now checked and ready to use. 3. Caution and warning lights test. 3A. Set the warn lights switch, on the engineer console, to its forward position, with a right click. 3B. Check that all warning lights illuminate, from left to right. On left overhead panel. Left and right engine temperature regulator. Flight data recorder. Hook hatch open. Set reserve. IFF, CD. Turn on RI65. On front overhead panel. Anti-ice system on. Left and right engine anti-ice. Left and right forward dust protection. Left and right aft dust protection. Section 1, 2, 3 and 4. First and second discharge, for each. Main hydraulic system on. Fire detector test. APU auto ignition and oil pressure normal. APU, RPM, normal and overspeed. Auto ignition and starter on. Left and right fuel valve closed. Crossfeed closed. Service pump on, left and right pumps on. Preheat, ignition and fuel heater working. On right overhead panel. Left and right disc protection on. Turn on rectifiers 1, 2 and 3. Equipment test. On right AC panel. External power on and PO 500, on. On co-pilot console. Doppler fail. On pilot console. Left and right engine chip. Left and right engine fuel filter. Left and right high engine vibration. Left and right high engine RPM. Left and right engine emergency power. Left and right engine low oil pressure. Left and right engine governor off. Battery in use. Chip main, intermediate and tail gearbox. 3C. Lamp test switch. Move to its flash position, with 2 left clicks. 3D. Set the flasher switch to on the right overhead console. 3E. Check that the following lights are flashing. Icing. Fire left engine, rigged engine, KO50, and transmission APU. Backup sys on. Gen 1 fail and Gen 2 fail. Fire, on pilot's console. Shut off left engine and right engine. 270-liter fuel, on co-pilot console. 3F. Flasher switch. Set to off, 3G. Set the lamp test switch to off, centered, with a right click. 4. Check fuel. Check that the helicopter has enough fuel, using the fuel quantity gauge and the fuel meter selector, on the co-pilot console. Press backspace, if you want to see a diagram of the fuel tank disposition of this helicopter. Press spacebar to skip it. On board the helicopter, fuel is located in 3 main fuel tanks. 2 saddle tanks are located on either side of fuselage and 1 service fuel cell is located in a container behind the main transmission. For increase in ferry range, 1 or 2 auxiliary fuel tanks may be installed inside the fuselage, on the cargo compartment, but that is not currently implemented in the simulator. 4A. Rotate the fuel meter selector, to the left position. The inner scale of the gauge displays the fuel remaining on the external left tank, in liters. Take note of the amount, and then move the selector to the right position. 4B. Again, the inner scale of the gauge displays the fuel remaining on the external right tank, in liters. Take note of the amount and then move the selector to the service position. This time, the inner scale of the gauge displays the fuel remaining on the service tank, in liters. Take note of the amount and then move the selector to the auxiliary position. 4D. The auxiliary tanks are not normally used, as they go inside the cargo compartment. On DCS they are not simulated. Finally, move the selector to the total position. 4C. The combined total fuel amount is displayed on the outer scale of the gauge. Compare the sum of all the tanks with this total, the figures should match. 4E. After this check procedure, leave the switch on the service position. For the next check, please move over to the pilot seat, by pressing 1. 5. Engine condition levers. Confirm that they are centered, on their middle detent. The levers are used to control each engine power setting during ground testing and in special flight conditions, such as failure of the engine governor system, or training purposes like practice landing with one engine shut off. Control them with the mouse, HOTAS or with the keys right Alt plus page down or page up, for the left lever. Right Shift plus page down or page up, for the right lever. 6. Throttle, on collective lever. Check that it is set to minimum, leftmost, using a HOTAS axis or the page down key. With the throttle turned to the full left position and the collective stick in the full down position, the engines operate at ground idle. Rotating the throttle control to the full open, clockwise, position allows the engine fuel control systems to maintain constant main rotor RPM. With full right throttle and the collective full down, the engines operate at flight idle. Note that both the pilot and the co-pilot have throttle control on their collective lever. 14. Connect external ground power. Ground power allows the pilot to operate all electric devices of the helicopter, before having the engine generators active. Even though this step is optional, we will perform it because of today's low ambient temperature, -12 degrees Celsius. This will allow the pilot to activate the battery heaters long before starting the engines. To contact ground crew and ask to connect ground power, press the HOTAS button that you have configured as press to talk, PTT, or use the \/ key. Press F8. Ground crew. Press F2. Ground electrical power. Press F1. On. Press spacebar once the external power is connected.
Copy. Ground power is now on.
14A. On the AC power panel, the external power on light will illuminate, indicating that the crew has connected the AC power cable. On the DC power panel, the external power on light will also illuminate, because on DCS both AC and DC ground cables are connected simultaneously. On the real aircraft they are separately connected. 14B. Check AC ground power. To check the AC ground power, before connecting it to the helicopter electric bus, turn the AC selector knob to the EXD power 1-2 position, to check that AC phase. Good. The AC voltmeter should measure between 204 and 208 volts. Next, advance the AC selector knob to the 2-3 position. Like with the previous phase, this one should also measure between 204 and 208 volts. Finally, advance the knob to the 3-1 position. Good. The AC voltmeter should still measure 204 to 208 volts, on this last position. After this check, we can safely connect the external AC ground power to our aircraft. 14C. AC external power switch. Set to on, up, to connect the AC bus to the ground power unit. 14D. Set rectifiers switches 1, 2 and 3 to on. The 27-volt DC bus is now fed from AC power through 3 6 kW rectifiers, 2 always active and the third is backup. 14E. Turn the DC selector knob to rect buses, to check the rectifier's voltage. Good. The DC voltmeter should measure between 27 and 29 volts. 14F. Inverter switches 115 and 36 volts. Set to auto, down, with a left click. 14G. Turn the DC check selector knob to EXD power, to check the ground DC voltage before connecting it to the DC bus. Good. The DC voltmeter should measure between 27 and 29 volts. 14H. DC external power switch. Set to on, up, to connect the external power to the helicopter DC electric system. 14I. Set rectifiers 1, 2 and 3 switches to off. Their lights will not illuminate, as the DC bus is now being powered from the ground power unit. 14J. Inverter 115 volts. Set to manual, up. Normally, the 115 volt bus is powered from the generator 2 or 1. When the generators are not operative, the bus will draw power from the battery bus via the PO500 inverter. The PO500 on lamp illuminates to signal this situation. 14K. Turn the AC selector knob to 115 volts, to check that the PO500 inverter is working properly. Good. The AC voltmeter should measure 115 volts. Now that we have full electrical power, let's enable heating. A. First, enable the battery's heater, by flipping the highlighted switch up. B. Next, enable the clock heater, by turning its switch up. C. Finally, enable both the left and right pitot tubes heaters. 10. Parking brake. Enable, with left shift plus W, to prevent the helicopter moving while starting its engines. Inspect the brake pressure gauge, located on the left side console. It should read between 30 to 36 kilograms per squared centimeter when the brakes are applied. 11. Rotor brake. Disengage by right-clicking on it, or with the keys right Ctrl plus R. If the rotor brake is not in the full-down position, a micro switch will prevent the engine start. 12. Cockpit and cabin lights. Turn on the red backlight of all the instruments and panels. The cockpit backlighting is divided into 2 groups, which have independent electrical supply circuits. For redundancy, the Group 1 is powered by the rectifier bus. The Group 2 is powered by the battery bus. 12A. Adjust the Group 1 and 2 backlight rheostats for the pilot console, left overhead panels and left triangle panel. 12B. Adjust the Group 1 and 2 backlight rheostats for the co-pilot console, right overhead panels and right triangle panel. You may want to do this from the co-pilot seat. 12C. Adjust the Group 1 and 2 backlight rheostats for the flight engineer console, center overhead panels and radio panels. You may want to do this from the flight engineer seat. 12D. The backlight of instruments added after the Mi-8 was modernized to the T model, is controlled by a separate 5.5 volts system. To turn it on, first switch the 5.5V switch to on, up, on the right triangle panel. Then, adjust the rheostat, which is located behind the co-pilot seat. 12V. You can also turn on 2 dome lights installed on the cockpit ceiling, on the pilot and co-pilot places. Each dome light contains 2 bulbs. One is white and the other is red, selectable with the highlighted switch. 13. Instruments transformer switch. Confirm it is set to main, on the engineer console. The single-phase 36-volt bus, which powers the engine and transmission monitoring instruments, draws its power from the 115-volt bus trough 2 redundant transformers, labeled main and standby. 17. Anti-collision light. Set to on. It will always operate, as it is connected to the battery bus. 18. Set navigation, rotor tips and position lights. As required. Set the flight data recorder switch to its manual, up, position. Good, wait a bit to check that its flight recorder light illuminates, to make sure that the tape drive mechanism operates normally. 19A. Service fuel pump. Set to on. This is the pump for the internal 415-liter fuel tank of the Mi-8. A green service pump on light will illuminate underneath. 19B. Left and right fuel pumps. Set to on. Green left pump on and right pump on lights will illuminate underneath. These pumps are for the 1040-liter right and 1130-liter left, external fuel tanks. Having all pumps on is not recommended for battery start on the real helicopter, but on DCS it doesn't seem to cause problems. 20. Fuel shutoff valves. Lift their covers and set to open, up. Their warning lamps underneath will turn off. 20B. Please, remember to close the switch covers. 21. Fire detector test switch. Confirm it is set to extinguish, up, to enable the fire extinguishing system. A. Turn generator 1 to on. Since the engine is not operating yet, its red warning light Gen 1 fail will illuminate. After 5 seconds, if the switchover circuit is good, the Gen 2 fail will illuminate too. This means the switchover took place, but since both engines are off, the red light for the generator 2 illuminates too. B. Turn generator 1 to off, to repeat the test for the other generator. C. Turn generator 2 to on. The red warning light Gen 2 fail will illuminate, as the engines are still not operative. Wait 5 seconds, if the switchover circuit is good, the Gen 1 fail will illuminate this time, meaning the switchover took place. D. Turn generator 2 to off, to end the test. Request start engine's permission, by contacting the air traffic controller of our current airbase. A. Select radio. Set the radio selector to UHF, on the SPU7 panel. Note that both pilot and co-pilot have this panel, you can use either one. The UHF position corresponds to the main R863, VHF, UHF, command radio of the Mi-8, and we will use it to contact ATC. Use the master knob to adjust the radio volume. B. Select preset, on the flight engineer console. The command radio can be tuned to a preset channel, or it can be tuned to a manual frequency. This time we will use the channel 16, so select preset. C. Set the command radio to AM, as on DCS the ATC always uses AM rather than FM modulation. D. Select channel 16, which is pre-programmed to the 132 MHz frequency of Senaki's ATC. E. Contact ATC by pressing the radio PTT. Note that the communications menu states at the top which radio are we currently using, R863 on this case. Select F5, ATC, F1, Senaki Kolki, F3, request startup. Press F12 to clear the communications menu. Press spacebar once ATC has granted the clearance.
Airfield 1-1. Complete, cleared for startup. Wind 035 at 3 meters per second.
The auxiliary power unit, a PU, supplies compressed air to crank the main engine compressor rotors during engine start. It can also be used as standby generator, to supply 27 volts DC power to the onboard electrical systems on the ground, and in flight if the main generators fail. Do not start the engines with the APU in DC generator mode. Make sure that the standby gen switch is set to off. 1. Crank switch. Set to start, up. The APU start sequence is automated and controlled by the APD9V start control box. This switch commands it for these situations: APU ground start, APU false start, APU crank cycle, APU shutdown. 3. Press the APU start button for 2 to 3 seconds. 5. Check that the APU exhaust gas temperature does not exceed 880 degrees Celsius maximum. 7. Monitor the nearby EGT, APU temperature gauge and air pressure gauge. Once they are stable, the auto ignition light will turn off. The stable EGT should be less than 720 degrees Celsius, and the air pressure should be within 1.2 to 2.0 kilograms per squared centimeter. The oil press normal and RPM normal lights should also have illuminated once the APU attains its normal speed. Eight. 115 and 36 volts inverter switches. Set to manual, up. First, move over to the pilot seat, by pressing 1. 9. Test the engine vibration monitor equipment, by press and hold the vibration sensor button. Check that the high vibration left-right engine, and the shut-off left-right engine enunciators illuminate, on the pilot console. If the nagging Natasha is active, then the oral message of left engine vibration and right engine vibration can be heard. "10. P-tit cold test. Press and hold the EGT sensor cold test button. Check that the power turbine inlet temperature gauge, P-tit, on the pilot console, indicates above 950 degrees Celsius. This indicates that the turbine temperature gauges are functional. If this test is to be done when the engines are operating, then use the EGT sensor hot test button, the gauge then marking 0 degrees. 11. Instruments transformers check, to confirm that both instruments transformers are operative. 11A. Take note of the APU air pressure value. 11B. Instruments transformer switch, set to off. 11C. Check that the APU air pressure drops to 0, as the gauge is now without electric power. 11D. Instrument transformer switch, set to standby. 11E. Confirm that the APU air pressure returns to its previous indication. 11F. Instrument transformer switch, set to main, to leave the main transformer enabled. 8.15, starting engines. Caution 1. Never engage the starter with the fuel shutoff valve switches turned off. Caution 2. Do not start the engines with the APU in DC generator mode on. There are 2 engines, left and right. Always start the downwind engine first. This is so that the exhaust gases from the first engine don't interfere with the starting of the other engine. On this mission, the wind sock in front of us indicates that the wind is coming from the left, so we will start the right engine first. 1. Confirm the APU has run for at least 1 minute. 2. APU air pressure gauge. Check it is within PPC limits. For this mission, at an airfield elevation of 43 feet and an ambient temperature of -12 degrees Celsius, the air pressure should be 2.05 kilograms per squared centimeter. Press backspace if you want to look at the PPC. Press spacebar to continue with the engine start. This is the performance planning card, used to determine what APU air pressure for engine start is required. Enter the graph from the bottom, at the line corresponding to the field elevation. Proceed vertically up to the current ambient temperature. Draw a line left to the required pressure. 3. Crank switch. Set to its start position, up. 4. Select the engine to start, with left-right switch. On this mission, the wind is coming from the left, so we will start the right engine first. 5. Start button. Press and hold for 2 or 3 seconds, to begin the engine start. The auto ignition light will illuminate, followed by the starter on light a few seconds later. If the auto ignition light doesn't illuminate, then most likely you forgot to release the rotor brake during the pre-start checks. 7. Once the RPM of the starting engine rises, move forward the corresponding engine stop lever overhead, to allow the fuel to reach the engine. Wait a bit, until the engine reaches idle RPM. (9) Check idle speed parameters. 9A. Engine RPM check it's within PPC limits. For this mission, N1 should be between 67 to 70%. Press backspace if you want to look at the PPC. Press spacebar to continue with the engine start. This is the performance planning card used to determine the engine limits at idle. Enter the graph from the bottom, at the line corresponding to the current ambient temperature. Proceed vertically up to the curves for minimum RPM, maximum RPM and maximum power turbine inlet temperature, PTIT. 9B. PTIT. Within PPC limits. For this mission it should be between 470 to 520 degrees Celsius. 9C. Engine oil pressure. Should be greater than 2 kilograms per squared centimeter. 9D. Gearbox oil pressure. Should be greater than 0.5 kilograms per squared centimeter. 9E. Rotor RPM check it's between 40 to 55%. 10A. Tested flight controls with main hydraulic system. A. Cyclic. Move forward, aft, left, and right, without depressing the force trim button. The cyclic should return to the original position. B. Cyclic. Move the cyclic, depress the force trim button, with the HOTAS or T key, and release. The cyclic must remain in the position where the trim was released. C. Cyclic. Return to neutral position, using trim reset, key left control plus T. D. Check pilot's pedals. Move pedals fore and aft. Check for smooth operation and return to neutral position. 10B. Tested flight controls with the backup hydraulic system. A. Set the main hydraulic system switch to off. Make sure that the backup system on annunciator comes on, and the main system on annunciator goes off. The backup hydraulic system pressure rises rapidly as it picks up the load, and varies within the limits of 42 to 73 kilograms per squared centimeter. B. Turn the main system switch back to the on position. Note that its annunciator remains off, as the active hydraulic system is still the backup one. C. Cyclic. Move forward, aft, left, and right, without depressing the force trim button. The cyclic should return to the original position. D. Cyclic. Move the cyclic, depress the force trim button, and release. The cyclic must remain in the position where the trim was released. E. Cyclic. Return to a neutral position, using trim reset, left control plus T. F. Check pilot's pedals. Move pedals fore and aft. Check for smooth operation and return to neutral position. G. Collective. Increase collective. 1 or 2 degrees of pitch angle is sufficient, and check that the blade pitch angle pointer has moved. H. Collective. Return to its full down lever position. Finally, select the main hydraulic system by depression of the backup system off button. And keep it depressed until the main system on annunciator comes on, and the backup system on annunciator goes out. 11. Second engine start. Follow the same procedure as with the first engine. A. APU cool down. 1 minute since the previous engine start. B. APU, EGT and air pressure. Within PPC limits. 11C. Crank switch. Set to its start, position. 11D. Engine selector switch. Set to left, as the right engine is already started. 11E. Start button. Press and hold for 2 to 3 seconds. 11G. Fuel shutoff lever. Once the N1 RPM increases, move forward. Wait a bit, until the engine reaches idle RPM. Check idle speed parameters for the second engine. 12A. Engine RPM check it's within PPC limits. For this mission, N1 should be between 67 to 70%. 12B. PTIC. Within PPC limits. For this mission it should be between 470 to 520 degrees Celsius. 12C. Engine oil pressure. Should be greater than 2 kilograms per squared centimeter. 12D. Gearbox oil pressure. Should be greater than 0.5 kilograms per squared centimeter. 12V. Rotor RPM check it's between 55 to 70%. Collective lever. Confirm it is set to minimum. Pull down. 1. Engines need to run at least 1 minute in idle, and until engine oil temperature exceeds at least 30 degrees Celsius, and main transmission it's over minus 15 degrees. Two. Throttle, on collective lever. Set to maximum. Use a HOTAS axis or the page up key. Engine RPM should go up, to around 85%, and the main rotor RPM, up to 93 to 97%. Three. Perform partial acceleration test. The partial acceleration check analyzes the engines and dynamics systems for proper response to power demand. 3A. Advance throttle smoothly, from ground idle power, full left, up to flight idle power, full right. Note the N1 RPM achieved upon stabilization. (3B). Return the throttle to ground idle power, full left. 3C. Advance the throttle rapidly, to the flight idle power setting. Note the N1 RPM achieved. 3D. This N1 level should not be more than 1 to 1.5% below the initial N1, and it must be reached within 3 to 6 seconds. PTIT should not exceed PPC limits. 4. Generators 1 and 2 switches. Set to on the AC power panel. Caution! Ensure that rotor RPM is above 88% prior to turning the generators on. If you are not using ground power, the 3 lights turn on rectifiers will illuminate on the DC power panel to remind you to turn on the 3 electric DC rectifiers. 4. Generator AC voltmeter check. 4A. AC voltmeter selector knob. Set to generator 1. Phases 1 and 2. On the voltmeter, confirm that the phase voltage is 200 to 205 volts. Next, advance the selector knob onto phases 2-3. Again, confirm that the phase voltage is between 200 to 205 volts. Finally, advance the AC selector knob onto phases 3-1. Check that the voltage still is between 200 to 205 volts. 4B. AC voltmeter selector knob. Set to generator 2, phases 1-2. On the voltmeter, confirm that the phase voltage is 200 to 205 volts. Next, advance the selector knob onto phases 2-3. Again, confirm that the phase voltage is between 200 to 205 volts. Finally, advance the AC selector knob onto phases 3-1. Check that the voltage still is between 200 to 205 volts. 4C. We will now check the 115 volts inverter. Advance the selector knob onto the 115V position. Confirm on the voltmeter that the voltage is between 109 to 121 volts. Note: you can adjust the voltage as necessary, using the voltage control rheostats located on the AC power panel. 5. Inverters 115 and 36 volts AC set to auto, down. 6. Rectifiers 1, 2 and 3, set to on. Their warning lights will turn off. 6. Rectifiers DC voltage check. Proceed as follows. 6A. DC voltmeter selector knob. Set to bus is red. Check the voltmeter, the reading should be between 27 to 29 volts. 6B. DC voltmeter selector knob. Set to bus is battery. Check the voltmeter, the reading should be between 27 to 29 volts. 7. Flash switch. Set the annunciator lights to flash or steady, as desired. A. Contact ground crew, and tell them to disconnect ground power. Press the HOTAS button that you have configured as press to talk, or use the / key. Press F8. Ground crew. Press F2. Ground electrical power. Press F2 again. Power off. Wait until the external ground power lights turns off, and then press spacebar to continue.
Copy. Ground power is now off.
B. External power switch, on the DC power panel. Set to off. C. External power switch, on the AC power panel. Set to off. 10. Enable gyros. A. Pilot's gyro horizon. Set to on, to power the pilot's attitude indicator. Its red flag should disappear. B. Gyro cutout switch. Set to on, to enable the VK53 gyro correction system. This system reduces accumulated error during prolonged unilateral acceleration, like increasing speed, braking, and bank turns. Correction cutout does not occur from abrupt and unsustained changes in flight conditions. C. Co-pilot's gyro horizon. Set to on, to power the co-pilot's attitude indicator. Its red flag should disappear. 9. On the pilot's console, uncage the attitude indicator, by click and holding its top right button until its horizon is leveled. Its red flag will show while uncaging. Repeat on the co-pilot's console. Uncage its attitude indicator. 11. Set the tail rotor pitch limiter to on. The red off light on the center console goes out to indicate that the system is powered. This system automatically adjusts the maximum tail rotor blade pitch angle based on air density and temperature. 11H. Pitch limiter control engage button. Press on the engineer console. Its red light illuminates to denote that the system is in test mode. 11I. Toggle test switch. Set to P by left clicking and hold. The indicator bar should deflect until it reaches the left vertical mark. (11J) Toggle test switch. Release by releasing the mouse button. The indicator bar will move to the right of center. (11K) Toggle test switch. Set to T by right-clicking and hold. The indicator bar should now deflect until it reaches the right vertical mark. 11L Toggle test switch. Release by releasing the mouse button. The indicator bar will return to its previous position, to the right of center. 11M. Pitch limiter control engage button. Release. By clicking on it, the red light should go out. 11M. Pitch limiter control engage button. Press. By clicking on it, the red light illuminates. Now, scroll the test knob to the right, until full right needle deflection. Pitch limiter power switch. C12. The red light goes out, and the needle will deflect full left. 11P. Pitch limiter power switch, on the overhead left triangle panel. Set to on. If the red light is still illuminated, click on it to exit test mode. 11Q. Needle will center based upon ambient conditions. 11R. Pitch limiter control engage button. Press. By clicking on it, the red light should illuminate. Now, center the needle using the knob adjustment. Clockwise moves the needle right, counterclockwise moves it to the left. Pitch limiter control engage button. Press. By clicking on it, the red light should go out and the tail rotor limiter system is now operative. P-8 hot test. Check only on first flight of the day. 13A. Note the temperature of both engines P-8. 13B. Press and hold the EGD, indicator hot, test button. Check that the power turbine inlet temperature gauge, P-8, on the pilot console, indicates below 100 degrees Celsius, for both engines. This confirms that the turbine temperature gauges are fully functional. 14. APU off button. Press and hold, to deactivate the APU. Check for a decrease in EGD, and a decrease in air pressure. The oil press normal at RPM normal advisory lights, will go out after a few seconds. 15. Start panel switches. Set to neutral positions. 15A. Engine start switch. 15B. APU, start switch. Set to its mid position. 15C. Engine select switch. Set to its central position. Engine trim check. To assist with setting a nominal rotor RPM of 95% for takeoff, the collective control handle includes a trim increase-decrease switch, to allow for gradual adjustment of the rotor RPM. The switch is barely visible on the left side of the pilot's collective. It is more visible on the co-pilot's collective. Use the keys Right Alt plus Numpad plus, to increment, and Right Alt plus Numpad, to decrement. Note: if 96 to 99% rotor RPM is not obtained when checking the upper rotor limit, warm up the oil in the main gearbox to between 40 and 60 degrees Celsius and repeat the check. Check pilot's trim switch. C. Throttle, full right. Check rotor RPM, should be between 93 to 97%. D. Main transmission oil temp, should be greater than 30 degrees Celsius. E. Collective pitch, increase to 2 degrees pitch angle. On the real Mi-8, this check is done with a 3 degrees pitch, but on DCS the parking brake is unable to keep the helicopter still if using more than 2 degrees. F. Engine trim switch, decrease to between 89 to 93% and stabilize. G. Engine trim switch. Increase to between 96 to 99% and stabilize. H. Engine trim switch. Set to 95%. I. Collective. Set to its full down position. Check co-pilot's engine trim switch. It is performed exactly the same as with the pilot's switch, so we will omit this part of the check to save time. 16. Power up the avionics systems. A. Doppler switch. Set to 1, to enable the Doppler system used for the radar altimeter, the hover indicator and for the radio navigation. B. COM radio switch. Set to 1, to enable the outro HF radio. D. Do not turn on the mic switch, as it will mess up a DCS radio communication. In real life is used for the crew intercommunicator. E. VHF, ADF interlock. Switch to on to enable ADF navigation. F. Press the accelerometer reset button, over the pilot console, to reset its previous readings. 17. Caucasus switch. Set to 1, to align the gyromagnetic compass. 19. Barometric altimeters. Set the pressure altimeter pointers to 0, on both the pilot and co-pilot consoles, and check that the barometric pressure display corresponds with the actual aerodrome value, plus minus 1.5 mercury millimeters. For Senaki Kolki Air Base, it is 760 millimeters. Radar altimeter switch. Set to 1, to activate the radio altimeter. The radar altimeter is now performing an initialization test, during which it will read 800 meters. The test will last 60 seconds and when it finishes, a warning tone will be heard, and the low altitude warning light, on its yellow knob, will illuminate. Wait a bit for the test to finish, and then press spacebar, once the knob light turns on. Now, rotate the radar altimeter yellow knob, using the mouse wheel, until the green low altitude index reaches 0. The warning light will then extinguish. Press spacebar once the light goes off. Finally, you can now set the low altitude index to the desired warning altitude, say 5 to 10 meters, to activate the low altitude alarm just before touchdown. 21. Enable Autopilot. Enable roll and pitch hold, by clicking on the central green light. You can use the mouse wheel over the light knob, to adjust its brightness. Autopilot test, on the engineer console. A. Depress the green on buttons for all the channels on the autopilot console. Yaw, roll and pitch, and altitude. All the green button lights should come on, and the 4 trim indicator pointers should be centered, when the flight controls are in a neutral position. B. Deflect the control stick, To make sure that the pointers R, roll, and P, pitch, of the indicator, respond to control inputs, the directions of control stick and indicator pointers movement should match. Caution! When testing the autopilot on the ground, move the pedals and control stick smoothly and not far from the neutral position, to avoid unwanted movement of the aircraft. C. Press the autopilot off button on your HOTAS, or the left shift plus left wing plus A keys. Confirm that the autopilot channels have disengaged, all their green lights should go off. D. Check the altitude channel, by pressing its altitude on green button. Its light should illuminate. Now, momentarily depress up the test switch, with a right click and hold. The indicator pointer A should move upward. Release the test switch. E. Now raise the collective lever a little, to a main rotor pitch of no more than 2 degrees. Engage the altitude channel again, and momentarily depress the test selector switch down with a left click and hold. F. This done, the pointer A should move downward. Return the collective lever to its lowermost position. The altitude autopilot should disengage automatically. G. Test now the autopilot directional channel. With the pedals set to neutral and feet removed from the pedals, press the yaw on button. Its green light should come on. H. Check that the pointer Y of the indicator is centered. Now, rotate the yaw knob at least 1.5 turns to the left or right. It should cause a rudder pedal movement in the same direction. I. Rotate the yaw knob, to return the pointer Y to its neutral centered position. J. Depress the yaw up button. The yaw and green light should go out. This step finishes the autopilot test. Congratulations! You have successfully finished this Mi-8 realistic cold start procedure, and the helicopter is ready to taxi. Press spacebar to exit this training mission.